In example number 2, we're asked to find the asymptotic behavior of a function f, which is given by x over 1 minus x. So let's just take a look at this function here. We know that when x is equal to 1, okay, since 1 is not in the domain, there's something going on here. Okay, so this right here implies that we need to do more investigating. Okay. Now, so let's go ahead and take a look what's happening right around that. I'm going to take the limit. The question is, what is the limit as x approaches 1, let's say from the left of this function? Well, now here's the thing about this function. First of all, x can't be equal to 1 because that puts 0 in the denominator. But what happens to the numbers as they're just a little bit to the left of the value 1? So here's the value 1. Okay, there's some issue going on here. And so what happens is, as I start plugging in numbers that are just a little bit on this side right here, okay, as I plug those guys in here, the numerator, okay, the numerator approaches a single number, okay? So if I were to split this, this would be the limit as x approaches 1 from the left of x over the limit as x approaches 1 from the left of 1 minus x. Now here's the problem. And this is what defines a vertical asymptote. If this limit goes to a number, L, some real number, which it does here, this goes to the number 1, and the denominator, the limit goes to 0, okay, then we've got what's called a vertical asymptote. So we have an imaginary vertical line that our function travels towards on that interval. Okay, so let's go ahead and take a look to see what is the function's behavior. Well, to do that, if we take a number that's really, really close to 1 on the left side, let's say right here, well, then the top gets really, really close to 1, and the bottom, 1 minus a number that's really, really close to it, but on the left side, is a positive small number. So positive and small. And so the overall effect is that the total number is going to be positive, and we're taking 1 and dividing it by an extremely small number. So it'll be positive and large. That's the overall impact. So to say a positive large number, in fact, as we get closer and closer to 1, this number gets smaller and smaller, and this number gets larger and larger. So we go towards positive infinity. Now the limit, this means that the limit does not exist because it doesn't approach an actual number. However, the behavior of the graph, this guy right here is defining the behavior of the graph. And so that means that towards this guy, we must be headed up, like that. Okay? Now what about over on this side? Well, we're going to apply the same logic. As we come in from the right side, so let's just change this to the right side. So these guys coming from the right side, this still approaches 1, this still approaches 0. So we have a situation where we have an asymptote, okay? Of course we do. So now let's go ahead and walk through which direction that asymptote is heading. So the limit of the top is x goes to 1. From the right side, we get 1. Now as x comes close to 1 from the right side, this number is larger than this number. And so the overall result is a small negative value. So when you take 1 and divide it by a super small negative value, you get a negative. Okay, that's the negative piece of it. And infinity is 1 divided by a small number. So what that means is, in this direction, as we get closer and closer here, we shoot down towards the negatives. Now, if you don't trust this logic here, go through and plug in some numbers that are really close to 1 from the left and really close to 1 from the right, and you'll see that you have this behavior. So that's the behavior for the vertical asymptote. But now they also ask us, what is the behavior as we head out in both directions? So what we want to know, what is the limit as x approaches infinity of f of x, and what is the limits as x approaches negative infinity? Let's leave it the same notation, of f of x. What that means is, oops, as negative infinity. So what that means is, this guy in yellow is what happens to the function as we go out this way, and the green is what happens to the function as we go out this way. These are called horizontal asymptotes. So in your 13-14 class, your pre-calculus class, when they talked about horizontal asymptotes, they were really talking about end behavior of the function. They were talking about the limit as f of x, what happens to the limit, what happens to the f of x values as x becomes really large in the positive direction or really large in the negative direction. So what happens with that? Well, let's take a look. The limit of this, okay, so let's do the green one first. The limit as x approaches positive infinity, so we go over in this direction, is given by x over 1 minus x. Now this function right here is equivalent to the following function, and this is important. It's equivalent to the function, if I divide every single guy by x, I get 1 over 1 divided by x minus 1. And you might say, why do we do that? Well, first, this guy is the same as this guy for all values that aren't where x is not 0. So that's cool. We can make the substitution. Now here, as x goes to infinity, the limits as x goes to infinity of 1 over the limits as x goes to infinity of 1 over x minus the limits as x goes to infinity of 1. So the limit as x becomes really large of the number 1 is just 1. Nothing happens to 1, it stays there. The limit as x becomes really large of this guy, 1 divided by a really large number goes towards 0. And here, as x goes to infinity of 1, nothing happens. It just stays at 1. So we work with this guy right here, and we get 1 over negative 1, which is negative 1. So that means way out here, we approach the value, here's negative 1, we approach that value, just like that. Okay, so let me erase this in green. Okay, so our function, we don't know what it does over here. We just know that as we go out, and let me erase all this because it'll be clearer if I can draw, if I've got more room here. What that means is that as we go way out here, really, really far, our function approaches a height of negative 1. It can do whatever it wants in between here. It can wave up and down, it can cross this line, it can do all sorts of things. But as we go here, it approaches negative 1. Now let's go ahead and look at in the negative direction. Okay, so over here on this side, we want to know what's happening to the function as we go this way. Well, what we're really asking is what is the limit as x approaches negative infinity of that same function, x over 1 minus x. Now what we're going to do is the same trick. We're going to say this is the limit as x approaches negative infinity of 1 over x minus 1. Now, we don't have to write this all out. Let's just go through this. As x goes towards negative infinity of 1, we get 1. As x goes towards negative infinity, this thing just becomes 0. And as x goes towards negative infinity of this guy, we get that minus 1. And so we again get 1 over negative 1, which is negative 1. So in this direction, I don't know whether I come from the top or whether I come from the bottom. Likely I come from the top. All I know is out in this direction, I approach the line 1. So again, this guy could come from the bottom. This guy could come from the top. There's more stuff that we have to go through to verify which way it's coming from, but we just know that this is the line. We approach -1 out here, and we approach -1 in this direction as well.